All right? So I'm going to resume the conversation. So this second part of the session is going to be focusing on the fruit. And before we dive into characterizing the time profiles of fruit maturation kinetics, let's reassemble a little bit what we expect considering what we have observed during period 1, 2, and 3. So during period 4, we are essentially going to study the rate at which sugar is loading into the berry. What do we expect? As we stand at Veraison, what do we expect for the next weeks? Well, let's imagine it's August 1st and we are in 2019 and we don't know what's ahead. Anyway, we can already expect the consequences that are going to be related to an average higher transpiration leaf area level. What does that mean? Well, it's a bit counterintuitive because we see bigger plants, but it also means a higher risk of water deficit. Why? Because the rate at which water is going to be depleted from the root reservoir is faster when the plant is transpiring more. And what is also sometimes a bit less counterintuitive when we see those big green plants is that they may hide a higher susceptibility to heat waves. Why? Because when heat wave occurs, there is less moisture in the air. The combined effect of air moisture and high temperature is actually something we can characterize with the deficit in vapor pressure. So this is an important notion. I'm just going to step back 1 second. The vapor pressure deficit is an agronomic metrics that we use to characterize how much of a dry oven it feels like when we step outside. It's actually the amount of pressure we need to apply to a given unit of air to make appear the first droplet of liquid water. And very often, we confuse symptoms that comes from the drought, the lack of moisture in the soil, with the lack of moisture in the air. So you will see in the next presentation, I'm going to try to really discriminate between those two, because I really feel the main issue that the wine industry is facing is the lack of moisture in the air, and we try to combat it with more moisture in the ground, and it's not a good way to do it. It actually worsens the symptoms. So vapor pressure deficit, when it's high on a large transpiring vine, what does it do? It creates cavitation. Cavitation is the apparition of air bubbles into the vascular tissues, and this is an irreversible phenomenon that jeopardizes photosynthetic activity, leading also to higher plant organs temperature. So that's already where our mindset can be at the start of period 4. And if we try to project a little bit what to expect in terms of sugar loading, well, we expect maturation profile to be slow. Why? Because we expect a higher leaf to fruit ratio due to period 2 being propensious to a high development of leaf area. We also expect a late start of sugar loading. We also expect to have larger berries because there was no period 3. And remember, period 3 can reduce the size of berry volume. So if there is no period 3, there is no reduction effect. And we also expect slower change in coloration. That's referring to the work of Castellarin and all the world of scientists there, showing that stresses during period 3 hasten the onset of berry coloration. So, again, what does it mean? Well, it means it's a good news for weak vigor sites. Why? Because on those weak vigor sites, there is naturally a limited water holding capacity, moderating the effect of heavy rain in May on an excessive development of leaf area. So if you have a lower transpiration leaf area being developed, it's also going to be less sensitive to high vapor pressure deficit, heat waves. Also, another thing compared to other years, in 2019, weak sites will have a longer period 2, an extended period 2, means larger leaf development, more photosynthetic capacity, and it also means a reduction of the risk to observe overexposure of the fruit to sun or to heat. Shorter period 3, it's particularly important in sites that typically show more susceptibility to high stresses. A shorter period 3, which is the period during which stresses develop, means actually more moderate stress, which favors, again, higher color, higher tannins, higher pigmented tannins, and no sugar loading blockage. However, this is a bad news for high vigor sites. A longer period 2, which can actually extend into the beginning of veraison, means a higher risk of disease pressure. No period 3 plus a high nitrogen level means also a reduction in flavonoids. No period 3 means no water deficit pre-veraison, with the carryover effect it means in terms of greater susceptibility to late season water deficit because we make fatter, larger xylem vessels, therefore more susceptible to brutal cavitations. That's what I summarized in my parenthesis, stronger vapor pressure deficit affecting larger leaf area. So it looks like you have larger vines, but it's actually less robust to resist the heat waves we observe late season. And on high vigor sites, even if they look like they are big, we may observe sugar loading blockage, and it's specifically what Cecilia will discuss in a minute. So just to introduce her talk, focusing on berry composition, I'd like to highlight a little bit those climatic variables, and let's see, despite the fact that Greg showed that temperature were lower in September, maybe that hides something in terms of the severity of some events. What I'm trying to say here is that even if an average is lower than what we expect, we may have some singular events that are more severe than the average. So that's why it's interesting to look at averages without being fooled by them. In order to do that, the simple metrics I have reported is starting after veraison to the 1st of September, which you will see in a moment marks the moment in time where most of the sugar loading stops. That is when the berry starts to be actively calling for sugar. You see that the average vapor pressure deficit maximum value, so when we have heat spikes, how can we quantify their severity, is actually higher in 2019 by 1 kilopascal. So that means that the draw exerted by atmospheric pressure is actually more intense in 2019 than it has been in 2018. And this occurred twice, 2 times more than in 2018. So we had 3 heat waves greater than 4.5 kilopascal, whereas 1 in 2018. On those days, photosynthetic activity stops. We have protein denaturations leading to color loss. And we expect a sugar loading to be disrupted. To which extent did that actually translate into berry maturation profiles? We'll see that in a minute. And then moving on to the period 5, the period during which sugar stops being accumulated, but during which color is still accumulating. Remember, sugar peaks, and then after that, color peaks in terms of accumulations. But we know that heat waves during that phase can also have a detrimental effect in terms of color degradation. Well, it's a little bit less of a divide in terms of average peak value for vapor pressure deficit. We are only 0.5 kilopascal ahead of where we were in 2018, but we have 3 more heat waves on average. So the number of days is with a decimal simply because of statistics. I have looked at 40 plus weather stations, and that's why we had on average in 2018 2.5 days of very severe heat waves, really shocking the vine's physiology, versus in 2019 where we had on average 5.5 such days, which brings an interesting question. Is it so important to focus on irrigation where we have a big issue focusing on VPD, which is something you treat with canopy manipulation and misters? So, in conclusion, before introducing Cecilia, keep in mind, 2019 bears the footprint of a high frequency of severe heat wave during sugar loading and color accumulations. If you put that in the context of high yield potential, more leaves than berries. Remember, the leaves are susceptible to making more water leaking into the atmosphere under heat waves. We are at greater risks of observing sugar blockages during the loading, during period 4. And we are also at risk of observing a delayed ripening, which is going to lead to a later coloration start. So unlike other years where we definitely harvest after the peak color is reached, maybe we won't see that. So before we collectively discuss that with the panel of wine growers, I'd like to invite Cecilia so that she discuss with us what has been the quantifiable impact of heat waves on sugar loading profile and the timing of the end of sugar loading. So Cecilia, thank you for sharing your insights.